Today you will be looking at function operations. Hello. Okay, so pretty much it should be review from what you did in Algebra 2, but essentially notice for addition, you're just going to add the two functions together. For subtraction, you'll subtract. For multiply, you will multiply. And then for divide, you will divide. Don't worry about that g of x cannot equal 0. We're not going to worry about domain. So notice we have several functions. We have an f of x, a g of x, an h of x, and a j of x. And we're just going to practice doing these function operations. So if we look at the first one, notice we're going to take f plus h. Zoom in a little so we can see them all. And I'm going to start off with my f function, which is the 2x minus 5. And I'm going to add that to the h function, the square root of x minus 6. Now this one is unique. I can't combine any like terms, so we're just going to stop there. If we look at b, we're going to take our g function first. So I'm going to use parentheses, 2x squared minus 3x minus 5. And we will subtract the f function, and I'll use parentheses again, 2x minus 5. Now, just like we talked about earlier in our function unit, if you are weak with distributing the negative through like this, you can change the negative to a plus and then change all signs in the parentheses. So 2x squared minus 3x minus 5 plus negative 2x plus 5, and then we just combine like terms. So notice, well, 2x squared minus 5x, and then the 5's cancel out. If we look at c, notice we'll do g of x, which is the 2x squared minus 3x minus 5, and then we'll divide by f, 2x minus 5. Now, just like in Algebra 2, when you simplify rational expressions, you have to make sure there is nothing else in common. So we're going to factor the numerator. If you recall from, depending on how your Algebra 2 teacher taught you, but you'll take the front factor times the back factor. And that ends up giving us 2 times negative 5, which is negative 10. And we list our factors of 10. We have 2 and 5 and 1 and 10. And I want to know which pair gives me this middle negative 3. Well, we know positive 2 and negative 5 give me that middle negative 3. So we'll set up our two sets of open parentheses. And notice we know when we distribute, when I multiply the first two together, I want it to equal 2x squared, which means one front will be a 2x. Ugh, so gross. One front will be a 2x and the other front will be an x. And then we have to ask ourselves, okay, I know of my two factors up here, which one is divisible by 2? Well, 2 is. So I'm asking myself in my brain, 2x times what number gives me positive 2x? Well, hopefully you recognize that's a 1. And then we know that negative 5, we know x times what gives me negative 5x? Well, negative 5. And then look what happens. Your 2x minus 5's cancel, and you're left with x plus 1. And that's it. If we look at D, notice we're going to do f times g of x. Okay, so f times g. We'll have r 2x minus 5, and then g, which is the 2x squared minus 3x minus 5, and then we distribute. So let's see, 2x times 2x squared would be 4x to the third power. 2x times negative 3x is negative 6x squared. Negative 5 times 2x squared is negative 10x squared. Negative 5 times negative 3x is positive 15x. And negative 5 times negative 5 is positive 25. And we clean it up. So 4x cubed minus 16x squared. I think I missed a negative 10x. I never multiplied this guy. I'm going to squish it in there. Plus 5x plus 25. And that's it for that one. And then if we look at E, notice it's probably easiest to do each of them. So if we do h, my function h evaluated at 7 would be the square root of 7 minus 6, which is the square root of 1, which is 1. Okay, and then I would do j of 7. Okay, so j of 7 would be 2 over 7 plus 1, which is 2 over 8, which reduces to 1/4. And then notice the operation in between is product. So we'll take these two numbers and multiply them together. So 1 times 1/4 is just 1/4. That's it. I want you to take a few minutes and try these example U-tries. Okay, so hopefully you found for A, when you add the two functions together, you do get 3x squared plus x minus 4. For B, when you subtract h from f, the square root of x plus 3 minus 3x minus 4. When you multiply f times g for C, 9x cubed plus 6x squared minus 32x minus 32. And then for D, when you divide f by g, the denominator does factor to 3x plus 4 times x minus 2, and then the 3x plus 4's cancel out. Now, a big mistake that I will also see students make is they think when you divide the same number, you get 0, when in reality, any number divided by itself is just 1. And that's all you need to know for function operations practice time. The end.